Okay, let's begin. We have June 2025, 6-3 is the variant. This is an S2 exam. Okay, let's begin. It says at a certain shop, customers arrive independently and randomly at a constant average of 23.4 per hour. Okay, find the probability that in a randomly chosen 1 minute period, at least two customers arrive. So at least two customers, at least two means greater than or equals to two. But I'm not talking about 1 hour, I'm talking about 1 minute. So lambda for 1 minute is going to be 23.4 divided by 60. Okay, so 0.39. So at least two means 1 minus probability of 1, 0 and 1. So 1 minus e power minus 0.39 and bracket 1 plus 0.39. Okay, that should give me a total of 0.0589 on my calculator. The random variable x denotes the number of customers who arrive in a randomly chosen 1 hour period. State a suitable approximating distribution for x, giving the values of any parameter. Okay. So lambda is large. Lambda is large, so use normal. When you use a normal distribution, then x follows a normal distribution with mean 23.4 and variance also 23.4. Okay, then use your approximating distribution to find between 20 and 30. So the first thing that you have to do is do continuity corrections 20.5 and 29.5. You convert them to z values 20.5 minus 23.4 divided by root of 23.4. Z 29.5 minus 23.4 over root of 23.4. Okay, so the numbers that going to get are minus 0.5995. So I will have to round that off to these three decimal places, right? So let me check. So 20.5 20.5 minus 23.4 divided by root of 23.4. Okay, minus 0.600. Okay, because it's 5995, I can't possibly read that from the table. So phi of 1.261 minus phi of minus 0.600. So 1 minus phi of 0.600. Okay, then let's quickly read from the table. I don't know if I have the table open, but I'm going to quickly open that for you and say that 0.600 is just 0.7257 and 1.261 1.261 8964. 0.622. Okay, that should be the final answer. Yes, that is correct. Question number 2. The lengths of pencils made at a factory are normally distributed. The standard deviation of the length is sigma centimeters, and the mean is supposed to be 10. And inspector thinks that the mean is actually greater than 10. So he takes a random sample of 50 produced at the factory and then finds the mean of 50 lenses 10.03. He then carries out a hypothesis test. He finds that the value of the test statistic is 1.995. So test statistic is x bar minus mu over sigma over root n. Okay, so let's find out the value of sigma. So that's 1.995, 10.03 minus 10 over sigma over root of 50. Okay, so this is just simply solving for 10.03 minus, this is just simply solving for sigma, 1.995. So sigma is 0.106. Okay, I think that should be the correct answer. Moving on, carry out the hypothesis test. So I have to do the entire hypothesis test. I can't just simply say that I'm just going to write down numbers down, but I will have to write the null and alternate hypothesis, draw my rejection region, and then continue. So supposed to be 10, actually greater than 10. Rejection region first. 1.96. Okay, that's the number that we're going to use. Okay, the test statistic is falling at 1.995. So that's here 1.995. So reject H naught. There is evidence to suggest that mean is greater than 10. Okay, explain whether it is necessary to use the central limit theorem in carrying out the test. No, the distribution was normal. No, the distribution was normal. Of lengths was normal. Okay. Okay, question number 3. I've already solved this, but I'm going to solve it again for the recording. It says a machine dispenses coffee into cups. The volume is given by a random sample of this. This result is summarized as follows. Unbiased estimate of mu is x bar, which is 46350 divided by 150. Okay, what is 46350 divided by 150 over 46350 divided by 150? 309. Okay, that's an exact answer. Unbiased estimate of sigma square is n over n minus 1 into the formula for variance. Okay, so 144,108,00 divided by 150. Okay, so calculating this, so 594.966. Three significant figures is 595. Calculate a 95% confidence interval. 95% confidence interval would be x bar minus z value, 97.5. So 97.5 is 1.96. 1.96 into sigma, which is root of 594.966 over root of 150. Okay, mu, and then the same thing again, just with a plus sign. Okay, let's type that onto our calculator and see if we are getting the correct numbers. It's 305 and 313. Okay. Okay. Then says another random sample of n cups is taken where n is between 100 and 120. 95% confidence interval for mu is calculated using the sample. You may assume that for large samples and bias estimates of sigma square are very similar. Without calculation, state whether this confidence interval would be wider or narrower than the confidence interval found in part 2. Give a reason for your answer. Okay, so the width of a confidence interval is 2 times z value to sigma over root n. Reducing the denominator will increase the value of sigma over root n, which means that the interval will be wider. Okay, I think that's enough explanation for this. Question number 4, it says Emma needs to choose one person at random from P, Q, R, and R. She plans to throw two fair coins and note the number n of heads. If n is 0, she will choose P. If n is 1, she will choose Q. If n is 2, she will choose R. Okay, by considering probabilities, so that the choice made by this method is not random. Okay, so 0 heads means probability of tail and tail, which is half into half, which is 1/4. Okay, probability of one head is probability of head tail plus probability of tail head, which is 1/2 to 1/2 plus 1/2 into 1/2. That gives me 1/2. Okay, and probability of two heads is also 1/4. So the probabilities are not equal. Therefore, the method is not random. Okay. Then it says later Emma has to choose two people at random from three people. Emma describe how it could use a single throw of a fair six-sided die to make this random choice. Now, remember that this question is different. It is asking you to choose two people in one throw. That means that the outcome should be assigned in such a way that even one turn results in two outcomes. Okay, how is that going to be possible? Now, two outcomes are not possible, but can we divide them into teams? Can I say that there's a team A, B, make teams of what are the teams? P, Q, and R. Of P, Q, P, R, and Q, R. Assign each team two numbers out of one, two, three, four, five, and six. Okay, each team will have a 2 out of 6 chance of being chosen. Okay, so I think that should be it. Yeah. Okay, I can describe it further. Say 1 and 2 gives me team PQ, and then 3 and 4 gives me PR, and so on. Okay, in this way, everyone will have an equal probability of being chosen. Okay, then okay, in herbaria, the masses in kilograms of N have distribution this. A certain footage in herbaria can take a maximum safe load of 1500 kgs. When N men stand on the bridge, the probability that the bridge is unsafe is probability of unsafe is less than 0.01. Okay, so probability of unsafe is less than 0. When is it unsafe? When is it unsafe? When the total mass is greater than 1500, right? That is when it's unsafe. Okay. So what is the distribution of the total? The distribution of the total should be 70.3 n and 5.9 square n. Okay, state a necessary assumption, find the maximum value of n. So assume, what is the necessary assumption? It says normal distribution, but I haven't told you if the sample is random. Assume that the sample is random. So you have to look for keywords. Okay. So in this case, then I have t is greater than 1500 minus 70.3 n divided by root of 5.9 square n is less than 0.01. So 1 minus phi of, I'm just solving a normal distribution from there. I can write this as 5.9 root n, so 0.99. I can do a phi inverse on this. Okay, I have a lot of space. What's phi inverse of 0.99? Phi inverse of 0.9 is 2.326. 2.326. Okay, cross multiplying will give me 2.326 into 5.9. Okay, now this is turned into a complicated sort of equation. Okay, how am I going to solve this? I think the easier way of solving this over to consider disguised quadratic equation and say that u equals to root n. So 13.7234u, 1500 minus 70.3 u squared. Okay, so I have ended up with a quadratic inequality then. Okay, solving the quadratic inequality, I will have to show you the quadratic formula. Okay, I'm first going to solve the equation. For a c over to a. Okay, let's put that onto my calculator to see if I get the correct answers. The u is coming out as 4.52 and u is coming out as minus 4.71523, let's say 523 and 718. Okay, okay, but those are not values for, those are values for u. I need to find out values for n. So what was my answer? It was u was between u is between minus 4.718 and 4.523 based on this inequality that I have here. Okay, u is basically root of n, so 4.523 and 4.718 negative. Okay, so modulus of n is less than 4.523. N should be 4.523 squared. 20.5. Okay, 20.5. So n is less than 20.5. So n is therefore 20. What about this one? If I try to solve this, this is An inequality can't be solved. Now, why can't it be solved? Because it's always true. Can't be solved because true for all values of n. Okay, what does that mean? That simply means that modulus of n is greater than minus 4.7. Not modulus of n, so sorry, root of n. Root of n is always a positive number. It always has to be greater than a negative number. So this inequality really doesn't work. This is something that you should know. You should be able to discard answers. Marking scheme converts it into an equation and solves it. But in order to understand why it was less than 20.5 and not 21, in this case, the answer is 20, not 21. You will have to figure this out. Okay. Okay. Question number 6. A random variable x has probability density function this, where a and b are constants. Show that a equals to 2 over b squared. Okay. Integrating from 0 to b equals to 1. Ax square over 2, ab square over 2, so ab square over 2 equals to 1. So a equals to 2 over b squared. That's easy. Find the probability of x less than ex equals to 4 over 9. I don't think this is symmetric. So I will first have to find out ex. Okay. So ex is 0 to b x f of x. So x ax. Ax square has to be integrated right now. So ax cube over 3, 0 to b. Okay. Then ab cube over 3 minus a0 cube over 3. So my expectation is ab cube over 3. Now I know something about a, that's 2 over b squared. So 2 over b squared into b cubed divided by 3. That cancels out. So my expectation is technically 2b over 3. So I am then asking you, what is the probability of x less than 2b over 3 equals to 4 over 9? That's what I'm asking you. So integrate from 0 to 2b over 3. The function ax. So ax square over 2 and 0 to b over 3. I have to show you 4 over 9. Okay, so I have to show you 4 over 9. That's what I'm going to do. I am going to say that a to b over 3 squared over 2 minus a 0 squared over 2. So a 4b squared over 9 multiplied by half. What is a? A is 2 over b squared. So 4 over 9 b squared to half. Okay. Question number 7, it says, this is a long question. Okay. There are multiple parts to this question. Let's see. I'm erasing all of this so that I can teach you in one go. And this is about, okay, in the past, 1/4 of a job applicants at a certain firm had a class degree. As a change is made in the job description, and the director of the firm believes that on average, the proportion of job applicants with first class degrees has decreased. So 1/4 of job applicants. So P was 0.25. Now the belief is that it's less than 0.25. Okay, in the month following the change, there are 35 job applicants, and R of these had first class degrees. So the test statistic is R. Okay. The firm carried out a hypothesis test at the 4% level to test the director's belief. Use a binomial distribution to find the largest value of R that would find sufficient evidence that the director's belief is correct. So I am technically asking you to find out the rejection region basically. Okay. So I want the probability to be less than 4%. So I'm going to start doing trial and error. Okay, R is the test statistic. So I'm going to start doing trial and error to figure out if what R is. So my gut feeling generally is to start with 2. So I'm going to add a probability of 0, 1, and 2 to see if I have crossed the rejection region or I'm still in the rejection region. So 35C 0.75 power 35.25 power 0. 35C 1. Okay, so binomial CD. Okay, let's accumulate up till 2, 35, and 0.25. So I am getting a very small number. It says 0.00334. Okay, that's very small. It is certainly less than 4%, but x is less than or equals to 3. Let's calculate that. Okay, let's calculate that. What do we get? 0.0136. Okay, that's slightly bigger, so better, but it's still less than 4%. Okay, probability of x less than or equals to 4. Let's calculate that. Okay, it's giving me 0.041. Okay, that's greater than 4%. So rejection region is 3. X is less than or equals to 3. R is therefore equals to 3. R was the greatest possible value at which you would reject the null hypothesis, right? So that is R. In another month, the director carries out a similar test at the 4% significance level using the 35 applicants from that month. Explain the meaning of a type 1 error in this context and state the probability of a type 1 error. So probability of type 1 is something that I can, borrow from the previous part and just say that it was 0.0136. Okay, I just have to state it. What is the meaning? Type 1 is when you reject H naught and H naught is true. In this case, you wrongly conclude that proportion of applicants has decreased when it is not. Okay, given the proportion of job applicants with first class degrees this year is actually 0.05. Find the probability of a type 2. So type 2 is basically acceptance region with new probability. So what is the acceptance region? The acceptance region has to be x is greater than or equals to 4. But I can't calculate greater than or equals to 4 because it's up till 35. So 0, 1, 2, and 3 has to be subtracted. In this case, I have to write 35C 0, 0.95 power 35, 0.05 power 0. Just quickly write these 35C1. On the exam also you have to write these. You can't just calculate directly. 0.95 power 34, 0.05 power 1, 0.95 power 33, 0.05 power 2, 0.95 power 32, and 0.05 power 3. Yeah. Okay. Let's calculate what that gives us. It gives us 0.09. Okay, that should be the correct answer, I think. Yeah, I think that's the correct answer. That brings us to the end of the exam. Thank you for watching.